We're talking about data science and AI awareness, two of the more powerful aspects of technology that are going to transform the way our society operates. So without further ado, I'll bring up Emmanuel Schanzer. How's it going with Bootstrap? And you'll take it away.
Awesome. All right. Well, hello, everybody. I'm really honored to be moderating this panel. We've got a great lineup of folks to talk to us about data science, machine learning, AI, help us sort of tease apart these issues. So I'll call out to the ether and say, let's get this panel in. Oh, here we go. Jeff and Jean, this is fantastic. So we're joined here by Jeff Kent from Cobb County Schools. He's a high school math teacher and computer science teacher, so he can, sort of dig into some of the intersection between those two. Mattia Bentley from Fayette County. She's a middle school computer science and also broadcasting teacher. It's really nice to have a media angle on this discussion of data science. I'm really excited for her input. We've got Gene Garcia from Microsoft. He's a principal software engineering manager. And of course, we've got Jonathan Reynolds as well from AI for All. He's the director of the AI for All summer programs. So you're getting a really nice mix of voices coming at this from different angles. And my hope is that I won't be talking much because you got some incredible panelists here that you want to hear from more than me. So I'm going to kick us off with just a starter question. And I've got a couple of canned ones, but if you have a question that comes up for you in the audience and you want to jump in, please just type it in and I'll be going through them as we move. So to kick us off, this one's going to go to everybody. And let's see. Jeff, why don't you start us off here and I'll just go around the panel. So for folks that are coming at this, what is the difference between statistics, data science, machine learning, and AI?
In my classes, as you said, I teach math and computer science. So I have kids coming from that mathematics side, the data science side, and the statistics side, and then from the machine learning and the artificial intelligence side. And so, kind of for me, it's putting all those groups together. So statistics is kind of like the tools. We use those statistical tools to do data science, which is really the analysis of all kinds of data. For machine learning, we use the tools of machine learning to actually strive towards artificial intelligence. And so I kind of look at those, the statistics and the machine learning, as the tools for the artificial intelligence and data science. And those two, when they merge, the world is really going to change.
Awesome. Thank you, Jeff. Jonathan, how about for you?
So I will echo that sentiment. Like AI is sort of the technology, right? Like that enables machines to like mimic human behavior, right? And act on that. All those other components are just like inputs, right? Like that enables AI to get to that point, right? Like, so they're essential to artificial intelligence, the end outputs. But yeah, it's the culminating factor is artificial intelligence after all of those inputs are put in.
Gene, I think you've got the mic.
Oh, okay. All right. So I would say that if you're looking at the spectrum of analytics, and you've got hindsight, insight, and foresight. More the statistical type of sciences, this is all more around the hindsight and insight to some extent, and then machine learning focused more on foresight. So that in the end, you've got descriptive analysis, you've got diagnostic, you've got predictive, and then you've got prescriptive, right? And the machine learning would be more towards the predictive and prescriptive, is how I would describe it.
Gotcha. And it looks like Batia may have stepped out to get some headphones. She was getting a double echo. So we may not get to hear her definition of these terms, but when she comes back, we've got some good questions for her. Jonathan, let me shift this over to you here. I mean, after a decade of pretty intense efforts from, like both political parties, right? CS for All was like one of the few things everybody all agreed on. Even now, after that decade, less than half of all students are taking computer science courses. And I think for a lot of teachers that may be in the audience or even parents, they're wondering, well, gosh, why is AI for All going to be more successful than CS for All? Or for the schools that sat on the sidelines of CS for All, why should they jump in now for AI for All?
So that's a good question, and interesting framing. I wouldn't necessarily say like the schools and districts who sat on the sideline. It's a known fact that there's a disparity, right? Like in who has access to computer science education. So less than half of students, right, like take a computer science course, and hopefully it's a robust computer science like offering, and not like, you know, a computer program class, right, like typing or something. But it's an access issue, right? Less than 51% of like schools across the country like have access to a computing curriculum. So we're starting off on an uneven playing field, right? So students just don't have access to the curriculum, means that they can't take it. I think that the advent of the AP CS Principles course in 2018, I believe, 2017, was a testament to that there's a huge desire, right, like to want to learn computing on the behalf of students, just by looking at the enrollment numbers for that computing AP course. So started off with like some enrollment, about like 40,000 students took the AP exam in the inaugural year. And last year it had climbed up to 117 or 18,000. And so that is a AP course that requires no like prerequisites. And so it was leveled the playing field like more evenly, so that folks could enter into the space. I would hope that the focus on artificial intelligence, to get to the specifics of your question, would sort of underscore the need for like more resources to be infused at the local level, right? Like to school districts and schools, to offer more robust computer science courses, and to employ the teachers who would teach them. With like AI for all, and the focus nationally on artificial intelligence and the pervasiveness of it, I hope that that underscores the importance of just like computing and computer science becoming a fundamental part of the just like the K through 12 like national curriculum. So that's the hope, at least on my part, that it'll underscore the need for students to develop those like prerequisite skills associated with computer science, and both will gain traction and take off.
Yeah, and I kind of just to follow up on what Jonathan, what you were saying, from a teaching perspective, I know that a lot of teachers, when we first started talking about the AP Computer Science Principles, teachers, we didn't know what we were doing. A lot of us, I know, when I was bringing it to our high school, I told my administrator, "Hey, this is a great new thing," and she said, "Awesome, you're going to teach it." And I said, "Well, the last class in computer science I'd taken was 1987. Have things changed since then?" And so, I really did have to do a lot of work to get caught up to where I needed to be able to teach the computer science principles class. But it's not a difficult build. And then as you get into it, I think that a lot of students too, when they get into it, they get really excited about it. And AI is that next big thing. I know we've all heard about that Target story, where Target went out and they had an artificial intelligence type of a program that, based on a purchaser's what a purchaser comes in and buys, they can predict whether that purchaser is pregnant or not. And so there was a father of a young girl who I guess received ads. I'm probably getting the details wrong, but received a bunch of ads from Target for pregnancy, and he went and complained to the manager of the Target and said, "Hey, look, why are you sending these things to my 14 or 15-year-old daughter talking about pregnancy? This is awful." Well, it turned out that Target knew, based on her purchases, that she was pregnant before the father knew. And so telling little stories like that, really get the kids excited. And I think that once teachers start teaching the class, they get excited about this stuff too. And it's not that big of a build to go from somebody, a gray-haired old former attorney who didn't know anything about computer science, to get to the point where you can teach it. And I think once you get to that point, just staying a little bit ahead of the kids, they are so enthusiastic that it builds enthusiasm for teachers. And I think that, going to that next step of the AI is something that, while teachers might be initially reluctant to do this or more nervous about it, there are so many resources out there, and it's so exciting for the kids. You can learn along with them. So from a teacher's perspective, I think it's a great direction that we're moving.
As a middle school teacher, we are piloting an AI program right now in Fayette County, and today is our second day with the new students, and we introduced the 5 big ideas for AI and kind of dived into just the first one, just being able to perceive, and they were so in tune and they were so excited about what they were learning with AI. Bringing it home and showing them that they have a relationship already, I think is a very easy way to get them into computer science where it has not been in middle school. Introducing this first. For instance, we talked about CGI today and showing them movies like Avenger and showing them what is actually happening behind the scenes, because I teach broadcasting as well, and then showing them how that transitions to what we see on the screen, and just to see the shock in their faces, like, oh, that really happens, and explain that all of that has to do with AI. And having them to understand that whenever they talk to Siri, whenever they talk to Alexa, whenever they ask for directions and instructions, we are already interacting with this type of technology. So instead of just being consumers of technologies, we can also be creators of technologies. And they were very excited. And like I say, this is just the second day. When we introduced this pilot last 9 weeks, it was so exciting for our students that many of them have already contacted the assistant principal, as well as their parents have contacted and reached out to sign back up for the class again because we didn't finish all of the units. So this is something that, because of the relationship we already have with AI, they're able to relate, they're able to receive, they're able to actually engage, enjoy, and achieve in this particular course.
That's awesome to hear, Batia. And actually, I've got a question that blends in really nicely with this. So I'll kick the mic back to you. In high school, it's pretty common. You see, students have a lot more choice. They have electives. And middle school, often, what we hear is, there's these kids got a lot of stuff they got to get done before they graduate. So I'm curious, given your experience, how do these subjects of data science, machine learning, and AI, how do they support the learning goals that are already on middle school teachers' plates? Where do you see it fitting?
I think it fits right in. When we talk about the main competencies that are needed for the 21st century successful student, transitioning from secondary to post-secondary, when we talk about the need of collaboration and the need of communication, when we bring in data science with that and being able to look at that and interpret those numbers, no matter what subject is being taught, whether it's science, and I oftentimes have my students to be able to relate, how can you apply what you're learning today into your other classes? Where have you seen statistics before? Where have you studied and analyzed data before and been able to pull and draw from that information and make conclusions and decisions based on that? Where have you been able to, within our technology and engineering course, where have you been able to utilize machine learning to train? And how do you pull all of that into artificial intelligence so that the technologies that we are utilizing are becoming smarter, they're becoming more intelligent, they're able to make choices based on how they've been trained, and to get their responses and for them to be able to make that connection is really eye-opening. And I think that brings in the excitement, because now it's not just academics and connections, it's not just academics and your elective courses. They now see how it's interrelated. They now see the connection between the academics as well as the connection courses, or the connection courses, or the exploratory courses, and how all of that comes together to give them real world experiences and opportunities.
Yep. And to go off that, computer science is a sort of interdisciplinary field in its nature, right? The computational thinking skills, right? Like the base knowledge that students gain when learning computer science is essential for every role that you can have in the world, right? Like in terms of a career, right? Like teaching students the complexities of how computers face solving complex problems, right? Like that's even if your job is not directly impacted by artificial intelligence or related to it, right? Like those are skills that foster success, right? Like in any role. And so, yeah, it's create that skill set in particular, right, is essential for all students to learn to be successful in whatever. I always say that I don't want everyone to become a computer scientist, but have everyone have the opportunity to, and part of that is sort of giving them the opportunity to take advantage of learning that skill set so they could be successful throughout. And we also need folks who are knowledgeable, right, like about like artificial intelligence and computer science, right, like in the professions that they have. If people become policymakers or lawmakers, right, AI and the technology that we develop won't get very far if there's like this inherent fear, right, like in legislative bodies across the world, right? So we need those folks in different roles to push, to push the technology so that like it could be used and utilized.
And to piggyback off of that, for our students to see us using data science, like on the spot, I would do a survey on the spot and have them to tell me, what do they want to learn next? How do they enjoy this? Is this something that we should continue to teach? And showing them how I pull their data, look at their data on the spot, and then be able to make a decision moving forward. And since we're piloting this program, to have them to actually be co-creators and co-designers and say, okay, this worked on this instance with us doing the graphic organizer or with the machine learning or programming Calypso robots, whereas this was not so interesting for us as we developed this curriculum for middle schoolers. It's amazing for them to see that it's not just a subject where they wonder, when am I going to use this again? They see me actually using this on the spot and making decisions off of it that they are recipients of now, as well as middle schoolers in the future. So it's really been effective and, again, engaging, enjoyable, and it's really something that I believe will draw more people into computer science. Those who come in with a preconceived notion that it's just programming or just coding or just this or just that, or it's just for this segment of population, they now see more. And that's what it's all about, exposing them, giving them opportunities to explore, to discover, and to create.
Batia, but before I bring Jean into the conversation with the next question, there's a question directed at you here from the main stage, which is just they wanted to catch the name of that program that you were saying the kids were excited about.
They were excited about, they've been excited about quite a few. Since we're piloting, we're trying a couple of different things. They were excited about Calypso. We also have dabbled into Code.org's AI program. We tested out Calypso AI, teachable machines. So there have been quite a few of them. I was recently researching with Bootstrap, and I saw some things in there that I want to kind of dive into as well and then start to incorporate within our curriculum. So it's quite a few, and just showing them that learning doesn't stop whenever you leave school. Even as an educator, being an example of a lifelong learner, realizing that you don't have to know everything about everything, as Jeff said, and showing them we do the research. This is how the research matters. This is how you can decipher that. This is how you can utilize that. And again, just showing them real world, even as a teacher, as an educator, not being necessarily a data scientist, but still performing those same types of duties and having the responses and the outcomes that make a difference.
Thanks, Batia. So Jean, I want to bring you back here. So speaking as you're the industry dude. You're the one here who's seeing sort of the outputs of the K-12 education system, and you work with data science, machine learning, AI. I mean, now that the chant is shifting from CS for all to be data science for everyone, I mean, there's only so many hours in the school day, right? And there's only so many classes in the master schedule. So, given that we're going to be sending, we hope our students, to do incredible work at companies like Microsoft, where do you want to see K-12 educators focus their attention? Are there things that teachers are spending a ton of time on now that you wish you're like, actually, no, it's this other thing? Or are there things you wish were being presented differently? How can we?
Yeah, I mean, I think it has to start with an excitement about what's possible across those disciplines. It's definitely not an either or. It has to be both, right? The data science and the computer science. But I think as an engineer, I would say focus more on the engineering. It's the applied science, right? Because when you tell the story from start to finish of the value that's being delivered through those disciplines, right? Through practical application of those disciplines, that's the starting place. It's the end-to-end story. And then how far you get into the details about how the different disciplines work, that's dependent on how much time you have, right? That's time dependent. But having that end-to-end story, in the business world, that's like the MVP, right? That's the minimum viable product. You got to have that end-to-end complete application, real world, scenarios to capture the student's imagination, I would say. And then being able to, once you have that curiosity, that excitement, then you start drilling into the science behind it all, to the extent that you have time. So it's not either; it's both.
Well, and Gene, I think not every educator has a clear sense for what you mean when you say, we want to focus on the engineering. Can you make it a little more concrete? Like, is there a thing that is happening in classrooms, or that you think is happening in classrooms because you see the kids who come to Microsoft, and that you can identify and say, here's what it would look like to do that same thing, but focused on engineering. So what does that mean?
Right. I would say that engineering is the practical, creating something from the underlying knowledge, from the underlying science. So that means lab oriented. That means hands-on. That means, from the Microsoft standpoint, it's quickly being able to stand up a lab in Azure and have the different working pieces kind of working from start to finish. Middle school, that might be difficult to have something simple enough, but high school, it's very much doable. So that you can, it's kind of like having maker spaces, right? It's being able to actually see something that you're building and how it has a measurable outcome. So whether that's a really cool dashboard that shows you, certain statistics that are unexpected within some kind of data set, or even getting to a place where, you have a machine learning example kind of, built in, being able to run that machine learning model and show some predictions. I think that's where you start. It's having that lab that you can then drill into. So like the engineering is very much a how to get this all working from start to finish. And so often, in the professional world, it's the data engineer that really is kind of has his and her hand in everything, and it's the data scientist that's very dependent on the data engineer to get what's needed in place to be able to do the data science. So I think the engineering is what makes it all very real and tangible, and then the data science is the underlying discipline.
And I think from a high school, you were talking about, the end-to-end kinds of things. There are things we can do as teachers. Just a quick example from each of my statistics, data science, and computer science class. Computer science students were making a rock, paper, scissors game. They were programming a rock, paper, scissors game. And they came up with, they would win 50% of the time. The computer would win 50% of the time. Some of the students were pulling in an AI where it basically said, okay, based on the feedback that, the input that the user was giving, what are the odds of me winning if I choose, say, rock, when the student choose, whatever. And so they did that, and they compared their results when the computer actually made predictions based on what the user's previous input was. And it was really interesting because they got to see, hey, this actually works. You can have better predictive power when you have the machine actually making predictions based on the data that's been input. So that was computer science. For statistics, my students create probability games. They make games of chance that people play and stuff. And then what a lot of students will do with that is they'll do programming as part of their data analytics and calculating the probabilities of things. Same kind of thing in there where they actually have, based on previous scores and previous play things that people have done. By the end of the day, the kids who do that, by the end of the period where they show their games, some of the kids who are doing some of that AI or machine learning, their games are it's almost impossible to beat the computers in their games. Whereas when you first start, it's kind of a 50-50 thing. Data science is the most fun thing. Georgia now has 2 new data science classes, a data science 1, data science 2. And for the data science 2, which we teach at my school, it's got to be a post AP statistics or post AP computer science principles. So we have kids with some of those underlying skill sets, and they can put those things together. And some of the things they're doing over half the class is well beyond my level of expertise. Like they come in and they take something and they run with it. You get them excited and they'll take a project that you give them, and the directions they will go will be far beyond where I go. And so I'll assign them a simple prompt for them to do, and the things that they come up with, it's almost like they're human machine learning. I mean, they're learning and they're expanding from what they've learned, and they teach their computers to do the same. So teach their computers. So definitely doable in high school.
That's awesome, Jeff. Thanks. This is sort of bringing us full circle to a little nibble of that first question I asked the whole panel about definitions. And I since you've got the math and CS background, you might be a great person to kick this off. I've been talking about data science for a long time. I was at the U.S. Department of Ed a couple months ago, and I hear this theme from everybody, industry and teachers and parents, which is, well, is data science like you're going to take a math class and you're going to add coding to it, or is it a CS class where now they have to learn some stats, or is it something bigger than either of those? Like how do you frame this math CS connection?
Yes, and yes. But the big thing is it really is something that's bigger. So basically, it's kind of like if you teach a kid how to do addition, you teach a kid how to do subtraction, you teach a kid multiplication and division. All these things, you put them together, they can actually go out and solve a lot of kinds of problems. So if a kid has the statistical tools, they can do a significance test. They have coding tools if they use R or Python, and they actually can run that test in R or Python. And then they have the additional ability to run this not just of the data that's fed to them, where they can go in and search a database and pull out the information. You really can solve a lot more problems when you put all these tools together. So making sure we have students who have those underlying tools, and you're not going to have all the students coming in with all the tools, but making sure they have enough tools that when you put those together really makes something huge. So data science pulls in computer science, pulls in the statistics, but it really makes something even better. So typically the first half of the semester or so, you're really differentiating between kids who have strong statistics background, but not such strong computer science, and vice versa, and some who have a little bit of both. And then for the second half of the course, you really can have them put those things together in a new course. And so I would say, yes, it's something bigger than both, but from those who are coming with a statistics background, yes, it's adding coding. For those with a coding background, yes, it's adding statistics. But at the end, it's a lot bigger than both.
I've also found that making sure that the information is relevant for middle schoolers whenever you're dealing with data science usually kind of takes the stigma and the uncomfortableness away from them. So if they're looking into things like food, all of them are interested in food in middle school. They can eat at any time. If you're looking at music, at fashion, sports, whatever it is that you can pull their interest in to use as a data set, they're more interested at that point, they're more engaged at that point, they're more likely to succeed versus just pulling random numbers and random data sets, is what I found. And I would definitely encourage that you do that and give them ownership in that, give them a voice in that, give them a choice in what data sets that they would like to utilize, where they can actually have control over the final product.
So I'm opening up the floor to folks. If they've got questions, that's the end of the canned ones. So I'll give folks a minute to type those in and see if we've got questions for the panel.
I'll add my thoughts a little bit around this. That it depending on what the focus is for a given class. I mean, there are a lot of different ways of teaching these subjects, right? And from an AI perspective, there's a basic understanding that's necessary just from a literacy standpoint, just from an understanding of how you're impacted in the world, right? Without having to go deep into the science, but understanding that fundamentally AI is about recognizing patterns and then predicting outcomes based off of tons of data, right? And how data really is the lifeblood of AI, and how collecting data is the name of the game for every industry. So all those underlying key points can be made at the middle school level for sure. And there's a ton of discussion that can be made around that. Like, it's important for people to recognize that their phones are gathering a lot of data about them, that your browsers are gathering a lot of data about you. And that's part of, I think, just a basic literacy in today's world.
So as as I'm reading the group chat here that's coming in, so Autumn has a question. She wants to hear more about AI for all. Specifically, how could this work with like a CS club? And Jonathan, I think this might be directed at you.
Yep. So AI for All, I direct the summer program, well, a new department called High School Pathways, where we incorporate like open learning, our open source AI curriculum, which we partner with schools and districts to infuse those curricular bites into the existing curriculum. And so it's developed to be executed from a interdisciplinary approach. Where like English teachers, right, like are invited to, right, like integrate it into their English curriculum, right, and teach students a little bit of AI that way. We also have those open learning curricular bites that are more technical in nature, right, like for the traditional CS students, right, so something for everyone. There's ways to like implement like those curricular bites or components of open learning in extracurricular activities like a robotics club. And then there's the summer programs like Sector that is under my direction, in which we partner with universities throughout the country to create summer intensives for students to sometimes go on the university's campuses in the summer and learn a robust artificial intelligence curriculum that's set up by us. That's comprised of this core curriculum with the fundamental tenets of like what artificial intelligence is. And so we partner with schools and school districts on a very like tailored basis to not only like do the open learning and summer programs pathways, but like also to figure out like what best works for you all in terms of integrating those like components into extracurriculars or the like formal education classrooms and things of that nature. So there's limitless possibilities about like how it can. And I can put my email in the chat if you want to connect offline to discuss the specifics.
I'll say too that some of the challenges around like maker spaces is that it's expensive to have a laser printer, a 3D printer, right? It's expensive to have a lot of these tools. A lot of the tools available that are cloud-based data science and data engineering tools and computer science tools are free to students, right? And so to the extent that you're able to build labs and curriculum around these free tools, that when the class is done, the students can continue to explore and build, right? I think that's hugely powerful. This is part of the value of these cloud resources that are largely serverless and really inexpensive, so much so that they can be given to students for free. So to the extent that you can kind of set them on a course and let them continue to explore, I think that helps as they're reaching the professional world. A lot of times when we're interviewing, we'll look at, show us some of your pet projects, right? And that ends up being the best kind of an interview because you see the passion that they have in their own projects.
So I'm gonna just first suggest all the panelists that we share our email addresses in the comment thread. Those of us, or if you're comfortable doing so, I think some people are looking to continue the conversation even after the music stops. And I'm not seeing any other questions right now, but please keep them coming. So I'll throw a bomb and say, one of the big questions that I hear as I'm making the rounds is some people are saying, look, telling kids that they have to learn some kind of programming to do AI it's too high a barrier, that's going to turn off some kids and that's not going to help them get engaged. And then I hear the other side of the story, which is, well, look, if we're getting kids amped about AI, but we're not giving them the tools to get started, are we helping them? So given we've got 4 panelists from 4 different angles, I'm wondering, I'll do this daytime talk show style. Can we get a direct answer, please? Is programming a must-have for an AI class in K-12? And of course, that you may have different answers depending on whether you're middle, elementary, high school. So I'll open up to the panel. What do y'all think? Programming required or not?
No, but it's nice.
I'll say not necessarily programming, but technology literacy. Yes, increasingly the tools that are used to deliver the technology are higher and higher levels of abstraction, where you don't necessarily need some low-level programming ability, but you do need the ability to think technically about the problem at hand and how to assemble really powerful pieces.
Yeah, oh, go ahead. I'm sorry.
I agree with Gene and Jeff with the middle school level, just ensuring that they are comfortable, again, with those 5 main competencies, with collaboration, with communication, computational thinking, complex problem solving, and just being willing to be creative, not expecting things to be handed to them or spoon-fed necessarily, but getting them comfortable with being innovative. It's a different type of teaching. It's a different type of educating this future generation. We're transitioning. So is programming necessarily required? Not necessarily, but I do agree with the fact that they should be literate in technology and understanding what and how it works behind the scenes.
Yeah, I'm going to cheat and agree with everyone on that topic. In middle school, no, not necessary, but the computational thought and computational thinking is like essential. And I think that my answer changes, right? Like as the grade levels go up.
Mm-hmm. All right. Well, I think we may have time for one more question. Yeah, let me, what the heck? I might as well throw another bomb. Are there competencies that wouldn't fall under the umbrella of math or computing that you think are absolutely essential for data science in K-12? What's something that the STEM folks are leaving out or forgetting that we need to keep in mind? And I'll direct this. We'll go Gene, Batia, Jeff, and then Jonathan for the last word.
I think we too often frame these set of disciplines as not creative, right? They're like science as being black and white and kind of this, cold discipline, and it's not. It's highly creative, and I would say that creative thinking is part of computer science. It is part of AI, and so I would just encourage that I don't know. That the lens applied to these disciplines is one of, excitement and creativity, not necessarily this kind of black and white world.
I agree as well. Again, that creative piece. When we talk about STEM, you have that art piece, and just showing students that there's a place for them in computer science. There's a place for them in artificial intelligence. You may not be interested in the stats of it. You may not be interested in the programming or the coding portion of it, but you're interested in the things that we utilize on an everyday basis. How do you think that we can make this better? How do we solve a problem? What problems are out there that we can utilize and solve? What do you see as an issue? And how can we apply the principles of computer science or AI, including data science, to address those issues and come up with relevant resources and relevant outcomes? Again, switching from just being consumers to also being creators.
I kind of go a little bit different. Yes, I think that the creativity is very important, but I think the logical side too, because there are people who need to programmers, data analysts, who need to actually have that logical thinking skill, set. And so being able to think logically and say, okay, what do I need to do to get from step A to step Z may require creativity, but it may just require, good old fashioned logic. How do I go from one step to another? Another thing that we haven't really touched on that I think is really, really important, especially as AI gets more and more powerful and closer to actual human thought, is ethics. I mean, I think that we really need to focus on, can we do it? Yeah, but should we do it? And if we do these things, we also need to make sure we're doing them ethically and properly and look at that. So I think that's a huge part of any class we teach in this realm.
Yep, I echo that sentiment. I was going to say ethics and the policy implications of the technology. because even if you don't work with it, if you're not around it, if you manage to not be around it on an everyday basis, which is an incredible feat to do, you will be impacted by it at some right, like at some time on more than one occasion, right? Like it impacts us. It's so pervasive in our lives, and so those two components are really critical to be integrated into sort of the technical education that's involved with AI.
Awesome. Well, I want to thank our panel. Really fantastic to hear all these different angles. For the folks out there in the cyber audience, I will say, having done a bunch of these kinds of panels, it is a rare treat to have the mix that we've got on this panel today: middle school, high school, math, broadcasting, industry, out of school, the whole thing. So thank you all for your lively discussion. There's some terrific breakouts coming up next. And if you're not sick of me, I'm doing one of them. So I may see some of you in the other room.
Yeah, I would definitely have to agree. That was a fantastic panel. Thank you all. That was, and again, like you said, that mix of perspective gives us a fuller understanding of the whole picture. So
Excellent.
thanks.
Thank you.
Thank you.
Thank you. Thanks.
We have one last series of breakout sessions. As Emmanuel said, he is doing one. I believe AI for All is in one. And what is the other session? Oh, yeah, somebody else from the DOE. Nicholas is going to talk about how to use data to drive your decisions at your school. So hopefully we'll see you back here right after the last session to do the last raffle and for us to wrap up. Hope you're enjoying the day.